multiply here. Or in general, we will have to provide some function or some delegate that can be used as a operation that we do during the aggregation. And in .NET 3.5, we have this func delegate that we can use, and that's largely motivated by functional programming, as we will see shortly. So first of all, we will use the op operation instead of the plus operator here. So we will call op with the first number as the first argument and the aggregation of all the remaining numbers as the second argument. And we will also give the delegate as an argument to the recursive call. And now we can use C# lambda expressions, which is another idea that comes from functional programming, to specify what kind of operation do we want to apply here. For the first call, I'll give it a lambda expression that simply adds two numbers. And for the second call, we'll use a lambda expression that multiplies two numbers. And if we run the code again, you can see that we still get the same results, but now we have a more generally useful function that's parameterized by taking a delegate, or in the functional terms, taking a function as an argument. So in this simple C# example, we've demonstrated a couple of essential functional concepts. We started by using immutable values instead of variables, because we never change a value of a variable in this whole code. Secondly, we take a look at recursion, because recursion is the functional way of expressing more complicated control structures. And as a last thing, we've looked at using functions as the argument, which is very useful because it lets us write functions that hide the difficult recursive part, and we can parameterize them just by specifying some part of their behavior. So now that we've learned a little bit about functional programming in general, let's look how the code would actually look in the F# language. If you want to start with F#, the best way is to create an F# script file, because to start with using F# you don't even need to create a project. And we will start by declaring a couple of values. So we can declare a value num and assign it some numeric constant, and we can create one value to represent some string. In F# you can select any code, and if you hit Alt Enter, it will be executed immediately in the F# interactive window, which you can see down here. And we can, for example, read the value of the num symbol, or we can write some simple expressions here, and so on. One interesting thing about value bindings in F# is that you don't have to write the type, but the type is still there because F# uses type inference to deduce what the type of a value is. So in this case we use integer constant or a string constant. So F# automatically infers that the type of this value is integer and that the type of this value is string. Let is a very important keyword in F# because you can use it to declare values, but also to declare a function. So if we want to declare a function, we'll write a simple function called 2times. We just use the let keyword again, but we also specify some arguments after the name of the symbol. And in the body of the 2times function, we'll just multiply n by 2. And we can again select the function, hit Alt Enter to compile it in the F# interactive, and then we can use it to multiply 42 by 2, and we can also use the symbol that we declared earlier, and so on. So if we wanted to write the sum numbers function, we would use let keyword again. Uh, this function will take two arguments. It will take the initial number of the range and the last number of the range. And as we've seen in C#, we will first write some condition to check if the first number of the range is more than the last one. In that case, we will simply return 0, and otherwise we will add the first number of the range to the sum of all the numbers from the initial number incremented by 1 to the last number. And there's one more minor point. When you're writing a function that's recursive in F#, you have to use the rec modifier. So now the code should work, and let's try it using the F# interactive window. So let's try summing numbers from 1 to 5, and as you can see, the result is again familiar 15. So let's now improve the function and let's turn it into the more general aggregate numbers function. So I'll change the name, and we'll again add two arguments. One to represent the initial value that we will use here instead of the hard-coded 0. And the second argument will be the function, the operation that should be used to aggregate the numbers. So we'll use the operation here instead of calling a plus operator, and I'll also propagate the arguments in the recursive call. Now, as you can see, if we write a function call, we simply write the name of the function or the symbol that represents the function, and then all the arguments to the functions separated by spaces. So if we compile this aggregate numbers function, we can now use it by calling it and giving it some initial value and lambda function. So the lambda function syntax in F# uses the fun keyword, but otherwise it's more or less the same. And let's again add numbers from 1 to 5. So I can select the code and evaluate it, and as you can see, the result is again 15. And if we wanted to multiply all the numbers, we would simply just change the initial value and the operator inside the lambda function, and the result would be 120. One minor note is that in F# you can use just the symbol of the operator, so we don't really have to write the lambda function here, and the results will be again exactly the same. So we wrote this function just to demonstrate some of the basic functional concepts, but let's now look at something more interesting. I'll declare a list value and I'll assign it to this construct, which is the F# syntax for initializing a list. So as you can see, we've created a list of numbers from 1 to 10. And if we want to work with lists, we can either do it directly by iterating over the list elements and process the list using recursion, but we will not look into that in this webcast. You can find more information in my book about F#, and we will instead use some of the existing functions that are already available in the F# library. So we will use the list filter function, which is a function that takes a list as the second argument and returns a list that's filtered that contains only some